proofs in this, but you're not going to be doing proofs on your own just yet. We're going to get a few more problems under our belt before we really start doing proofs. So here we go. All right, a little review. Let's go through all these angle types. So if I say angle 1 and angle 5 are congruent, those would be corresponding angles. If I say angle 3 and angle 5 are congruent, those are alternate interiors. If I say angle 3 and angle 6 add up to 180, those are same side interiors. If angle 2 and angle 7 make 180 also, then those are same side exteriors. And then let's do one more pair. If I say that angle 1 is congruent to angle 7, those are alternate exterior angles. So those are the 5 angle pairs that you really should know. There's also one more that I kind of just assume you know, like angle 2 and angle 4, those are vertical angles. So I assume you know those already as well. So mainly 6 pairs of angles that we need in order to be successful with this chapter. Alright, so all of these theorems are going to be converses of the ones that you learned before. Converses just take it and they reverse it. Before, it would say two lines in a transversal, two parallel lines in a transversal, then corresponding angles are congruent. Well, now we're saying that if we have two lines in a transversal, but we don't know they're parallel yet, and the corresponding angles are congruent, then that makes the two lines parallel. It just reverses what we had before. So saying if angle 1 is congruent to angle 2, then A is parallel to B. Okay? Alright, converse of alternate interior angles theorem. Same deal. So if the alternate interior angles are congruent, so if angle 1 is congruent to angle 2, then the lines are parallel, so A is parallel to B. Converse of same side interior angles. So if angle 1 plus angle 2 make 180, then the two lines are parallel, so A is parallel to B. Okay, so it's just reversing what we did before. Alright, so let's run a proof here just so you can see another proof. First step every single time is going to be given. Okay, so you just write down the given, you copy them straight as they show up. We don't do anything different. Okay, something else I do whenever I write down the given is I go over here and I mark my picture. So they said angle 1 is congruent to angle 2, so we're going to put little arcs on them to show that they are congruent. Alright, we want to show that this should say A is parallel to B. Terrible typo. Okay, so we want to show that those are parallel, and it says proof of theorem 3.5. Well, if we go back, theorem 3.5 is converse of alternate interior angles. Therefore, we cannot use that theorem to prove itself. So we can't just automatically jump to this, say, converse of alternate interior angles and be done. Okay, we have to get there some other way. So if we look at our picture, we have angle 1 and angle 3 that are vertical angles, so they're congruent. So we'll put angle 1 is congruent to angle 3 by vertical angles theorem. Then we can do a little transitive substitution kind of thing. We've got angle 1 is congruent to angle 2 and angle 1 is congruent to angle 3. So that means angle 2 is congruent to angle 3 by transitive property or by substitution, however you see that, because sometimes they kind of look like the same thing. Alright, so if we have angle 2 congruent to angle 3, that means that our lines have to be parallel because angle 2 and angle 3 are corresponding angles, and if the corresponding angles are congruent, then our lines are parallel. So that would be converse of corresponding angles postulate. Anytime you're doing a proof, and your last line or your proof step is a set of parallel lines, you show that the lines are parallel, then it's going to be a converse of something. And then we just figure it out from there. Alright, so what do you say? I give you this picture, and I say this. Angle 1 is congruent to angle 2. And I want to know which lines, if any of them, have to be parallel. So if you look at this, angle 1 and angle 2 look like alternate interior angles. So that means that this line would have to be parallel to this line in order for those to be alternate interior angles and for those to be parallel. So we would have to have ED parallel to CK. Alright, converse of alternate exterior angles. So this is saying two lines transversal. If you have angle 1 congruent to angle 2 like this, the alternate interior exterior angles, then the lines are parallel. So A is parallel to B. Alright, converse of same side exterior. So let's say if the same side exterior angles are supplementary, so angle 1 plus angle 3 equals 180, then the lines are parallel. So A is parallel to B. Alright, let's run another proof. First step, always, always, always is a given. Whenever I ask you what's the first step, you should be able to give that to me even if you have no idea how to do the rest of the proof. Okay? And then we go over to our picture and we mark it. It says proof of theorem 3.7. So we look back and we say theorem 3.7 is alternate exterior angles. We cannot use the alternate exterior angles theorem to prove this. We have to come up with some other way. Let's see if we can do it like the last one. Angle 1 and angle 4 are vertical angles, so they're congruent. So angle 1 is congruent to angle 4 by the vertical angles theorem. Alright, then we did some substitution and transitive property last time. So if we have angle 1 is congruent to angle 2 and angle 1 is congruent to angle 4, that tells us that angle 2 has to be congruent to angle 4 by substitution or transitive property, however you see that. Alright, and then we look at it and we say, well, angle 2 and angle 4 look like corresponding angles, so that means that the lines have to be parallel by converse of corresponding angles postulate. I hope you guys see how I'm abbreviating everything. That's kind of how I expect you to abbreviate it. Don't take it down to one letter because some of the acronyms are going to look exactly the same. Alright, so let's say I give you a problem, and this is more like what your homework is going to look like. I want an X that will make these two lines parallel. So we kind of have to assume they're parallel in order to know how to set up the problem. If I look at this angle and this angle that they gave me, those are corresponding. So they have to be congruent in order for the lines to be parallel. So I'm going to set them equal to each other and figure out what X has to be in order for that to happen. Okay? So then we solve it. And we get X equals 17. So that means if I plug in a 17 right here where X is, so I take 2 times 17, get 34 plus 6, that's 40 degrees. Well, that's the same as that one. So that's what we want. We want them to be corresponding. We want them to be congruent. So now the lines would be parallel because of that. Alright, and one more. I figured we'd try a hard one today. This is more like a real proof. So I give you that this line is parallel to this line, and I give you this line is parallel to this line. Okay, so everything's parallel to each other. I want to prove, and sometimes it helps to put a little mark on these. I want to prove that angle 1 is congruent to angle 5. Okay, so somehow you have to find an angle that links angle 1 and angle 5. And you can't insert any more into the picture, so that means we can't number ones that aren't already numbered, and that sort of thing. Alright? Start with the first step. And we copy it just as it comes. We don't change a thing. We marked our picture already, so now we're ready to roll. Okay? First thing I see is I see vertical angles like crazy. Okay? I see that angle 1 is congruent to angle 2, and I see that angle 4 is congruent to angle 5. Those are all vertical angles. Let's name them, because once I put them in my proof, then I can use them for things. Okay? So angle 1 congruent to 2, 4 is congruent to 5. Alright, now we have to figure out a link between angle 1 and angle 5 in order to do this. And I see this 3 sitting here. And I say, what can I do with 3 that's really going to be worth something? So I know that angle 2 plus angle 3 equals 180 because they're same side interiors. Okay? I also see that 3 and 4 add up to 180 because they are also same side interiors. If they have the same reason, we can put them in the same step of the proof if we want. Okay? Now, let's do a whole lot of substitution. Let's see what happens here, okay? First thing, both of these equations equal 180, so they have to equal each other. And that's a property I use quite a bit. Okay? That's just a substitution. Straight substitution, no funny business. Alright, if you look at that equation, you see how there's an angle 3 on both sides? We can subtract that off and have angle 2 equals angle 4 already. So I just did a little subtraction. Now, let's go back and use those vertical angles that we had before. What was angle 2 equal to? Angle 1 from up here in step number 2. Okay. What was angle 4 equal to? Go back up here, angle 5. What did we need to prove? Angle 1 is congruent to angle 5. And we did that by substitution because I took 2 out, I put 1 in its place. I took 4 out, and I put 5 in its place. Proof. Voila. We'll get better at them as we go.